Could you introduce yourself?
Yes, of course. My name is Sitnik. I work on the .NET team, where my job is to build a performance culture and to prevent from regressions, detect existing ones, and make .NET Core even faster.
Hi Adam. Why writing high-performance code matters?
So first of all, if your app is not responsive, your customers get angry and you lose them, so you lose the money. Moreover, if you optimize the code, you can save money on capacity. For example, you need fewer server licenses, you spend less money. Also, CPU generates heat, and heat contributes to global warming. So we can also say that whenever you make your app faster, you actually make this planet a better place to live. Obviously, we laugh, but this is serious, and yeah. So
Okay.
money.
During your talk, you mentioned a lot of tools to investigate the performance. Could you list them?
Yes. So I believe that if you are facing a performance problem on Windows and you are developing using Visual Studio and you can reproduce the problem locally, then you should try with Visual Studio Profiler. This should be your first choice. Otherwise, if you're on Windows but you cannot reproduce the problem locally, then most probably Purview. It's great for profiling performance production problems. But if you are on Unix, you can give a try to .NET Trace. It's a new .NET Global tool. It allows for tracing and profiling .NET Core 3.0 applications. Moreover, it doesn't require you to run as admin, and it's simply great.
.NET Trace is already released?
Yes.
Okay, great. And what are the most common problems when we talk about the performance?
I would say most probably locks, taking locks even if you don't need to, or taking them too often. Choosing really complex solutions over simple solutions. Software engineers very often tend to complicate stuff, and when you think about something and you take a look at this next day, you are very often like, I don't need two loops, I can cache this, I can move it out of loop. So locks. Yeah, also very often using wrong data structures, like people very often use list or array to search by key when they should be using dictionary or hash set. Yeah. That's the first things that come to my mind.
Okay. And when we are facing a performance problem, it could be memory leaks or CPUs and that kind of stuff. What are the, basic steps that we should check first?
So I recommend to start with CPU investigation, and first of all we need to check if our process is CPU bound. So in Purview we have this metric/interval thing which tells us how CPU bound given process is. If it's CPU bound, then we stay with CPU investigation. If it's not CPU bound, we need to do I/O investigation, and when it's CPU bound, it can be just simple computations or things that we need to improve, but we can also be allocating a lot of memory, and then we can see in the profiler that we spent too much time in garbage collector.
And last, very important question, correctness or performance?
This is what a lot of software engineers tend to forget. Doing performance is always cool and fun. However, correctness should be always our top priority. So people are going to be happy with a correct program that doesn't work very fast, and nobody is going to be happy about a program that fails very fast. So yes, keep the tests, run them, use them, write more tests, and tune the perf in the meantime.
Okay. Thanks, Adam.
Thank you.